Hello everyone, wishing you all a very good morning. I hope all of you are fine. Good morning, Vaini. Got so many messages from so many students. Good morning, everyone. Shri, Deepak, Goli, Sainath, Satvika, Sai Tarun, Tejasvi, everyone. I hope all of you are fine. Yes, beta. Satvika, this is ID that you send your messages. I can see it nicely on this ID. Okay, good morning, Hannah. I hope all of you are fine. Okay. So again, we start the class with the same instructions. Keep your mobile cameras off. Why I'm doing good? I just have a bit of cold, I think, just now. I don't know how. So I'm just okay. Sai Tarun, send the messages on the other ID beta. Okay. Good morning, Santosh. I hope everyone is doing fine. Tell me, how was your paper in the last Sunday? Satvik, I'm fine, beta. I hope you are good. I hope you are good. How was your paper? In the on the last Sunday, you had a paper, right? Great. How much did you score, Satvika? What was your score? 95 out of 100. So you got one question wrong. Well done. Very well done. I'm impressed. The paper was not easy. And if you have done nicely, so good. That is good. What is the overall score, Satvika, that you got? Overall entire out of 300, how much did you score? Out of 300, 200. And 95 is in physics. So you are not very interested in the other two subjects, I guess. Anyway, see, it doesn't matter in JEE mains especially how much you score in individual subject. You don't have an individual cutoff. I hope you know it. What matters is your overall score. And I always feel, I always believe, and I always have this feeling that my students should always get maximum marks in physics. If it would be very nice if you get 100 in all three. I would be happy. But if physics is less, I feel very disappointed. I feel very disappointed on myself, not you. That probably I was not able to teach you physics good enough that you could get maximum marks in that. So that's a failure on my part. If my students don't get maximum marks in physics, try. I try to do whatever. Varun, 56, not bad. It's good. I hope you are improving and you are understanding. You understanding what mistakes you are making. 75, Deepak, that is great. What about your overall score? Well done, Varun. Well, keep it up, keep it up, keep it up, keep it up. See, remember, don't worry, Satvika, it will improve. Your marks will improve. Don't worry. Again, I keep on telling you, kids, bacho, that we are doing a very small portion of the syllabus, right? Now, if you get very high marks, that means you have done nicely. Deepak, 155 is not bad. It's good. It's not bad from any angles. No, it's not bad. It's good. You can always improve. See, it's a very small chapter that we are dealing with. Last day I was discussing the NEET paper with the other batch, and up till Newton's law, they only had 4 questions out of 45 in those Newton's law. Up till this point that we have covered. But those 4 questions, I showed it to them. They were pretty simple. They could have easily done it. Only 4 questions had come out of 45 from the part that we had done up till now. That means it's all luck. It's all your day, probably. You might get a lot of questions on the part that we have studied till now, or you may get only 4 or 5. They only got 4 or 5. I mean, they mean the people who had given. Yes, but it was 720 marks, and it was 720 marks, and okay, that's great. The colleges are opening. That is great. So, what I'm saying is, if you get good marks, that means this small portion you have prepared well. But then you'll have to make sure that all the portions that we are going to do, small portions, you keep up that level. If you're not getting good marks here, don't worry. Don't need to worry. There might not be any question coming from this part. So we have not lost on anything, beta. We have not lost on anything. So don't get overexcited. Don't get too depressed. You will have to cover it. The journey has only started. If I talk about physics, we have only done maybe 1/5 or 1/6 of the portion of 11th standard, not the entire one. Only 1/5 or 1/6 of the 11th standard we have done. Long way to go. Keep up your spirit. Tell me if you don't understand anything so that I can help you in understanding it better. So that's my request. We'll great. Okay, Varun, that's good. The pattern keeps on changing. Right now, the pattern is you get 30 questions. Out of them, 20 are compulsory, and the rest 10 you get a choice. So you have to do only 5 out of those 10, right? Okay. So we begin our journey for today's class. Can anyone remind me what was the last thing we did in yesterday's? The last class. Does anyone remember what we did in the last class? What was the last question? Yes, Vaini, what's your doubt? Ask me. The test that we had on, I don't remember questions like this, beta. I need to have the question. Then only I can please explain 23rd question. I'll see, Satvika, which question you are talking about. I'll have to see. I'll discuss it. Don't worry. I'll have to see which question you are talking about. Graph question. What was the question? I don't seem to recollect it. I don't have the paper. That is the problem. So I don't have the question with me. So let me see if I can find out that question. Don't worry. Send me a photo of that question. We'll discuss it. Okay. I'll find it out. I'll find out the question that you are referring to. Okay. I'll see it from the sheet that I have, and then I'll discuss it. Okay. Yeah, I understand. Screenshot is not possible. I'll ask office people to give me the paper, and then I'll see your question, which question you are talking about, and I'll discuss it. Is it okay, Satvika? Vaini? I don't have the paper, so I don't remember the question better. Okay. I'll explain all the questions. Don't worry. Don't have to worry about questions. I'll explain all the questions. Okay. I'll see. I have a list of the questions. So I'll see it. If I remember it, I'll post it in the group. Okay. Anyways, what were we talking about? I think we were discussing a question in the last class. The question probably was like this. Thermal point, thermal conductivity. That is not, is that what I am teaching you? Thermal point and thermal conductivity. I get confused. So you are basically asking about a topic which the other sir is teaching you, right? Is that clear? Is that the point? Okay, we'll discuss it. Don't worry. I'll find it out. I'll discuss it. Okay, I think this was the question that we were doing in the last class. Do we remember this? There was a 2 kg block. There was a 3 kg block. And I asked you to find out the acceleration of the blocks, the tension in the string, and the normal reaction. Yes or no? Let us quickly go about and answer this question. The first thing is draw a sketch. Sketch is there. Number 2, isolate the bodies. Bodies are far away from each other, isolated. Number 3, draw the free body diagram. Let us start with the tension P T, only one string, T, T. Don't have to worry about this. Now let us draw the free body diagram of this. This is 20, this is T. We draw the free body diagram of this. This is 30, this is N, normal reaction. Now, the first question is, where is the system going to move? The only one way, the only one direction in which the system is going to move is this way, right? This block will go down and this block will go right. Do we understand this? Yes or no? The 2 kg block moves down and the 3 kg block moves to the right. And the next question is, if I call the acceleration of the 2 kg block as A downwards, what will be the acceleration of the 3 kg block which is moving rightwards? Can anyone tell me? I've called the acceleration of 2 kg block as downwards A. What will be the acceleration of the 3 kg block rightwards? Who will tell me the answer for this one? What will be the acceleration of the 3 kg block rightwards? If the acceleration of 2 kg block is A downwards. No one? Satvika, Tejasvi, Ajay, Venu, Arpit. 4, 20. Maybe you're telling me the answers. I'm just asking you a small question. If this acceleration of this block is A downwards, the acceleration of this block will be A rightwards. Do we agree on this? Can I have some reason that we agree on this? The acceleration of the two blocks would be same in magnitude. One will be A downwards, the other one will be A rightwards. I only have 7 people saying yes, not good. Yashwant, some roll numbers. Vijay, Surendra, Siri, Siddharth, Sai, Reddy, Padmakant, Dinesh, Sai, Nath, Kevin, Kartik, Ankati, Deepak, Shashank, Charita, Sai Tarun, Raju, we are all there. Ajay, send some numbers. Rahul. Okay. Now, as soon as I have this, let us go about and write the equation of these blocks. 20 is downwards. T is upwards. Blue one. Acceleration is A, it is downward. So what will be the equation of this block? It is moving downward with an acceleration A. What will be the equation of this block? Acceleration is downwards. T is downwards. What is the acceleration of this block? What is the equation of this block? 20 minus T is equal to MA. M is 2A. That is equation number 1. Equation of this block. Do we understand this? Yes or no? Do we understand this? Okay. Now let us move on to the next block. Let us move on to the next block and see. 2 kg block is moving down. This block is moving right. It cannot move up and down. If you look at up and down, the up force is N. The down force is 30. I can make the equation of this block along x-axis. No, along y-axis. It is not going to move along y-axis. So normal reaction N would be 30. Do we all agree on this? This is the equation that I get from the y-axis, the yellow one. Okay, we seem to agree. Now, let us see what is happening on the x-axis. On the x-axis, I have T. I have T, which is rightwards. I also have A, which I've assumed rightwards. There is no force leftwards. So what is the equation along x-axis? What is the equation along x-axis? T is equal to MA. M is 3. T is equal to 3A. This is the equation. Oops, wrong color. I get it from the x-axis. Do we all agree on this? The x-axis equation, the green one. T is equal to 3A. Let me call this equation as equation number 2. How do I find the answer? I add equation number 1 and equation number 2. As soon as I add it, T gets cancelled. I have 20 equates 5A. I have 20 equates 5A. So my A becomes 4 meter per second square. That is correct. I get A as 4 meter per second square. Now I can put the value of A here, or I can put the value of A here. I would get the value of T. My T will be 12 Newton. So I get both the answers, the answer for acceleration and the answer for tension. Do we all agree on this? Yes or no? Can I have raised hand that we understand this, sir? I've lowered all hands. Let me see how many of you understand this. I also have some answers on the chat. Karthik gave me the answer. Goli gave me the answer. Vaini is saying yes, sir, yes, sir. Teja is also saying yes, sir, yes, sir. And I have 15 more people saying yes, sir. That means Satvika is also saying yes. That means we have got our answers, and that is great going. If we have got our answers here, let me now again make a question and see what is the answer in this particular case. So I have a 4 kg block here. I have a 6 kg block here. And on this block, I have applied a force of 40 Newton. This is question number 2. What is the acceleration of the two blocks? Remember, this is 40 Newtons. Acceleration of the two blocks, the tension in the string, and the normal reaction from ground. You will have 2 minutes to solve this question. Your time starts now. Are we all there trying the questions? Can I have some raised hands of all the people, all the children who are trying this question? Karthik, Deepak, strike, then. Well done. That is good. What about Sai Sarda, Shashank, Karthik, Sumant, Navya? And you're not trying the question. Veronica, Vamshi, then I have some numbers starting with 3. Surendra, Sri, Siddharth, Satvika. I guess you are trying the question also. Reddy, Padmakant, Goli, Dinesh, Kevin, Teja, where are you, beta? I hope you are trying the question. Yes or no? Okay, anyone has any sort of an answer? Anything that looks like an answer? Again, I repeat, answers don't matter. What matters is whether you are trying the question or not. Vahini has given me some answers. N is 60, T is 24. Good, well done, Vahini. What about acceleration? Answers are not important. The only important aspect that I am looking at is whether you are getting you are trying the question or not. Answer don't matter, right or wrong doesn't matter. Okay, let us start solving this question. First step, sketch there. Isolate the body, don't need isolated. Number 3, draw the free body diagram. I start from T, 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 and T. Then I go on this block. The only other force is 40 newtons. Here, yes or no? 40 newtons here. Here I have 60 newtons. Here I have N, normal reaction N. Now I have the free body diagram of this body A and body B. Now you must understand what are the possibilities here. Don't forget that there is a 40 Newton force here. There is a 40 Newton force here. Yes, Santosh, you are getting it right. And there is a 40 Newton force here. Now remember, there is a difference between this question and the previous one. There is a difference between this question and the previous one. Can anyone tell me what is the difference? Apart from the difference in the masses, what is the difference that you see between question number 1 and question number 2? Hanak has also come with an answer. Hanak, that is correct. What is the difference between question number 1 and question number 2? Extra 400 newtons, not 440. That's why I need extra 40 newtons. What is this extra 40 newtons going to do? Now again, let us come back to our question. What is this extra 40 Newton going to do? Try to understand what I am saying here. See, in the previous question, there was no force here. There was no force here. So the only way, the first question, the only way the system could have moved was downwards. This block should have gone downwards and this block should have gone leftwards. That was the only possibility in question number 1. But here in question number 2, since you have an extra force 40 Newton on this block, what is this 40 Newton going to do? This 40 Newton, look at the green arrow. This 40 Newton is trying to pull the block towards left. If the 6 kg block goes towards left, this block has to go towards upwards. So in this question, we have two possibilities. Either the system moves towards red. Red means 4 kg block moves down, 6 kg block moves right, or the system can move towards green, red and green. Green means 4 kg block moves upwards and 6 kg block move leftward. Is it clear? So far, so good. Can I have raised hand? That's yes, sir. So far, so good. You understand that there is a difference between the first one and this one. So far, so good. Only 5 people have understood this. No. If you not understood this, then the rest of the question is going to get more difficult. Sai, Shashank, Karthik, Navya, all these old numbers, Jashwant, Vijay, Surendra, Siri, Siddharth, Satvika, Sai Darshak, Reddy, Padmakant, Dinesh, Goli, Kevin, Shashank, Charita, Raju, Vinay, Ajay, Rahul, 2105 MPC. Okay, so there are two possibilities here, the red one or the green one. Now, many a time, almost all the time, you will encounter such question where you have two possibilities. Either it can go this way or it can go that way. Then you will have to think which way it is going. How will you find out which way it is going? It is very simple. Whatever way there is more force, it will go that way. Whatever force there is, whatever way there is more force, it will go that way. Now look at what are the forces which is trying to take it towards right or take it towards left. Now, as you can see, the force that is going to take it towards right or downwards right or downwards, is 40 Newton. It is trying to pull it down there. Now, if the other force is less than 40, it will move down. If the other force is more than 40, it will move up. But when you look at the other side, you again find 40. 40 is trying to pull it down. 40 is trying to take it right. What happens? What happens? Nothing happens. It remains at, yes, Kohli, it remains at rest. It does not go anywhere. Similar question came in IIT 1997. 97. That is the IIT that I gave, not this one. We were kept on two inclined planes, and there was friction there. Some more elements coming into it. And it was asked, what is the acceleration? What is the value of friction force? And so on. I looked at the question and I said, nah, it cannot be so simple in an IIT. Let me skip it. I skipped it. I went on to other questions. Some of my friends got caught, and that question consumed around half an hour, and they never got the answer, because when we were taking the motion towards right, it was coming negative. When they were taking the motion towards left, it was coming negative. In the examination hall, they panicked. Oh no, something wrong. And they kept on working on the question, wasted time. I moved on. That question was also question at rest. I will show you that question. That question also was at rest. Friction was there, and they were on an incline, nothing else. And that was a very tough JEE that I gave. This system remains at rest. If it remains at rest, acceleration becomes 0. It does not go anywhere. It does not go anywhere. Now look at the upward forces, look at the downward forces. Upward is T, downward is 40. What is the equation for this gentleman? The equation for this gentleman is T is equal to 40. Yes or no? Do we understand this? T is 40. We agree on this. T is 40. T is 40. T is 40. We can also get this T is equal to 40 from this equation. See, there is T here, there is 40 here. If you look at the equation on x-axis, for the upper block also, you will get T as 40 because nobody moves. Do we understand this? The green one, whether you look at the green one for the 4 kg block or you look at the green one for the 6 kg block, T is 40, doesn't matter how you look at it. Look at the normal reaction. There is no motion on y-axis as well. So the next answer is N is equal to 60. These are your answers. Do we understand this? The force, Varun, which is trying to pull it down, is 40. The force which is trying to pull it up is also 40. 40 newtons is trying to take it downwards. 40 newtons trying to take it leftwards. If this block moves leftward, this block moves upwards. So the 40 newtons is the force which is same on both sides. The block does not go anywhere. The system remains at rest. Acceleration becomes 0. Do we understand this? Can I have some raise hand now that we understand this, sir? So remember, only 5 people have understood this. Remember that whenever there is a question, you must always see whether or not, well done, Varun, whether the block is moving this side or that side. Just use common sense, nothing else. Am I clear now? Shall I move? Tell me one thing, did we do any question of pulleys in the first class? Did we do any question of pulleys? Atwood machine, we call it. Did we do any question on Atwood machine? And with whom I did those questions? I remember that I have done question on Atwood machine. With whom I did this question? I am getting confused. Let me have a look at what we did in the last class. Yes, we did question on Atwood's machine. F net is equal to MA. We got the solution. Then we did a question here. Yes, we did a question. We did two questions, in fact, on the Atwood's machine. Someone was getting me confused. We did questions on Atwood machine. Okay, now. Yes, we did it. We did. We'll do more questions. Don't worry. We'll do more questions. Don't worry. Nothing to worry here. See, when I am there is nothing to worry. Even if we have done questions, we'll still do more questions. Don't worry. I've got lots of questions for you guys. Don't worry. Now, this is the question that you are going to do. Let me bring it on your screen. Let me make it bigger. I think this is good enough. And here it comes. I think it is there on the board, right? Now, this is the same type of question that came in the IIT that I was talking about. The only difference here is there is no friction here. The only thing they did was put friction, and that created all those doubts in everyone's mind. Two blocks M1 and M2 are placed on a smooth inclined plane as shown in the figure. They are released from rest. M1 is √3 kgs. M2 is 1 kg. Angles are given as 30 degrees and 60 degrees. And you have the question, acceleration of mass M1 and M2, tension in the string, net force on the pulley. You may not do the last part, but I think you should be able to do the first part. What is the mass of M1? It is √3 kg. Mass of M2 is 1 kg. Your time starts now. How will you do this question? Don't worry, don't panic. Do simple things correctly and you will get the answer. Do simple things correctly and you will get the answer. Shall I help you out or you will be able to do this? Do you need any help? Let me also make my thing. How many of you are trying this question? Can I have a show of strength, raise of hands? That we are doing this question, sir. Don't worry. We have got it covered. You don't have to do it. We can do it, sir. We have that much confidence that we'll be able to pull it off. Only 4 people are trying it. Not good. Not very pleased with this side. That only 4 kids are trying the question. Very disappointed. Try the question. You might find it to be difficult. It may not be difficult, beta. Difficulty is only in your head. It's not present anywhere else. Difficulty is only in the head. I'll give you 1 more minute. You will say, sir, it is less time. I know, beta. I made my diagram in the time I was talking with you. So you see, I can't waste time. I've made the diagram. Let me start solving the question. First step, sketch. Sketch is there. Step number 2, isolate the bodies. Our bodies are far away from each other. Let me not waste time on that. Step number 3, draw free body diagram. Let us start with tension. T, 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 and T. Tensions are done. Tensions are done. What about the next step? Draw a free body diagram. Let me start with this. This will be root 3 multiplied by G. I can write it 10 into root 3 or root 3 into G. Okay. Then I will have normal reaction coming from here. Let me call it as N1. Let me draw the free body diagram of this. Yeah, this might confuse you, so I'll just write it as 10 root 3 so that you don't get confused. 10 root 3, this is 10. Free body diagrams are done. What do I do next? I'll have to take suitable axes as X and Y. What are the suitable axes here? As you can see, this will be my Y axis and this would be my X axis. Do we understand this? X and Y will be like this. For this gentleman, the Y axis would be like this and the X axis would be like this. Do we understand this? So far so good? Can I have raised hand? So far so good, sir? Nothing has changed. We are following the same steps. No one has understood this. We're following the same steps. We have not changed any of the steps. Following the same trend. Okay. What do I see here? What do I see here? This 10 root 3 is going downwards. I'll have to resolve it. We all know how to resolve it. One component will be here. Mg cos theta, cos of 30 is how much? Cos of 30 is how much? Root 3 by 2. Yes or no? Root 3 by 2. So it is root 3 into root 3 by 2. How much it becomes? 10 root 3 into root 3 by 2. So it becomes 15 newtons here. This becomes 15 newtons. Yes or no? Please raise your hands and tell me. Okay. This becomes 10 root 3 sine theta. Sine of 30 is half. 10 root 3 by 2. That means it becomes 5 root 3. This becomes 5 root 3. 5 root 3 is going like this. 15 is going like this. As soon as I make this, please remember, as soon as I do this, I don't need this. This force is done. So I cut it from here. So far, so good. Please raise your hands and tell me so far, so good, sir. Okay. Let us now repeat the same steps for the other one. This is 10. This is 10. So this one will become 10 cos 60. Cos 60 is how much? Cos 60 is half. 10 cos 60 becomes 5. So 5 comes here. This gentleman over here becomes 10 sine 30. Sine 60 is root 3 by 2. 10 into root 3 by 2. It is 5 root 3. Do we get this or not? Do we get this or not? Can I have some raise hand that we get this, sir? Okay. Now as soon as I do this, this is gone. So I just take it out. So far so good? So far so good? Now tell me, okay, I have not drawn the normal reaction of this one. Let me draw the normal reaction N2. Now, the first equation that I can make, there is no motion along y-axis. For this block, N1 is going up, 15 is going down. What will be the equation for this block in the y direction? Please tell me. Who will tell me this? Y-axis equation for this block. Blue one. N1 becomes equal to 15. Do we agree? Yes or no? Do we agree? N1 is 15. We agree. Yes, Winey. Thanks for your appreciation. Let us now move on to the other block. It also does not move along y-axis. Along y-axis, upwards is N2. Downwards is 5. Let me write the equation here. Y-axis. Y-axis. Here also blue, 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 blue. N2 becomes 5. Don't need to worry. Painted blue. Sky is blue. Y-axis is blue. So far, so good. Now let us see where to find the acceleration of the blocks. Let us see where does the system move. Let us see where does the system move. There are two possibilities here. One possibility is this one moves down. If this one moves down, this gentleman moves up. If this moves down with an acceleration A, this one moves up with an acceleration A. The yellow one. Do we see this? Blue and yellow. Blue and yellow. This is one possibility. Possibility number one. Do we agree on this possibility? This is one possibility. What is the other possibility? What is the other possibility? The other possibility is like this. This moves upwards with an acceleration A. This will move downwards with an acceleration A. This possibility is shown. Oh, yellow is not a good color for this. I'll put it green. This possibility is shown in green. The green possibility. The yellow possibility is this going down, this going up. The green possibility is this going down, this going up. Let us see which way this happens. Which way it happens. I look at the force here, the pink one, which is trying to pull it here, 5√3. I look at the force here, and you see Deepak, Anak, yes, you see pink, 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 5√3, 5√3. 5√3 is trying to pull it down here. 5√3 is trying to pull it down here. Where will it go? It does not go anywhere. Does not go anywhere. My acceleration becomes 0. My acceleration becomes 0. Yes, Karthik doesn't move. So this question has taken the same inspiration from the question that I was talking about that came in the year 1997. That's why we did this question. The 1997 question will also do, but that involves friction. So when we do friction, we will be doing that question. Don't worry. Acceleration is 0. That is good. Let us find the value of tension. How will I find the value of tension? Tension T is up. Green one. 5√3 is downwards. Dark green one. So we can now write the equation from here. T is equal to 5√3. The green one. You can also do the same thing from the next block, other block. See, T is up, green one, 5√3 is down, the dark green one, colors getting superimposed. So even if I do it from here, I will get the same answer. Do we understand this, or it has gone above our heads and we don't understand anything of this? I've made a lot of colors, made it colorful. I am a colorful person. I may not be knowing the name of the colors, but still, I like colors. I like blue, I like red, green, yellow. I know these 4 colors: black, white, pink, brown. And I have lived my life with those 5, 6 colors. Do we understand this? Can I have raised hand that we understand this, sir? Shreya is there. Shreya understands this. Anna, Karthik understands this. Veronica, Satvika, Tejasvi, Vahini, Janu, Shreya, Sainath. Only these many. What about the others? Rahul, Ajay, Venu, Raju, Charita, Chaturiteja, Santosh, Jayashankar, Sashank, Kevin, Triveni, Goli, where are you beta? Dinesh, Padmakant, Jashwant, Sai, Satvika, Siddharth, Surendra, all these numbers starting with 3, Kartik, Shashank, Sai Sarda, we are all there. You understand this? Yes or no? Okay. That is good. Okay, Deepak, I may not have seen your hand. Human error. Forgive me for that. Okay. That does this question. Now, I'll do one more question here. And this one more question will concentrate more on, it will be a simple question. It will be a simple question. But then we need to do one of this type so that you understand how to do questions of this nature. And here comes the question. Wow. What is the question? As always is the case, I have a block of mass 5 kg. I also have a string. But here the string is somewhat different. Can you point out what is different here in this string? This string now has a length. Why I need to give the length? Because it also has a mass. 10 kg is the mass of this string. This string has mass. It is not a massless string. This string has mass. 5 kg block attached to a 10 kg string. Length of the string is 10 meters. And I applied a force of 45 newtons on the string. Obviously, the string cannot stretch, but the string has mass. And I'm simply asking, what is the what? I marked 2 points A and B. What is the acceleration of the block? What is the acceleration of the block? Please tell me. Will the tension in the string same at all points? Will the tension in the string same at all points? No. It will be different at different points, right? And that is the point that I want to make here. It will be different at different points. Find the tension in the string at point A and tension in the string at point B, and the normal reaction, the usual suspect, is also there. Acceleration of the block, which will be same as the acceleration of the string because string is also moving. Tension at point A, tension at point B, normal reaction on the block from the ground. The question starts, your time also starts. Normal reaction is 50. Yes, Wahi, that is correct. Normal reaction is 50. Yes, you are correct. Normal reaction is 50. Anything else that you want to add, Vahini? See, we must be ready to encounter all types of questions. Different questions will bring different scenarios. Tension at point A is 5. Well done, Vahini. How did you get 5? Good. If you got an answer, that is great. Well done. Good. I'll give you one more minute. Is this an interesting question? Yes or no? How many of you find this question interesting? Something has changed. Only Yashwant Kumar finds it interesting. So heartbreaking. None of you find it interesting. Four people find it interesting. Anak, Deepak, Vahini, Yashwant. What about the others? Okay, now the interesting people are increasing. I hope whosoever is interested is also trying the question. Vijayalakshmi, Sai Sada, Sashank, Kartik, Veronica, all these old numbers starting with 3, Shriya, Siddhi, Siddharth, Satvika. Satvika, where are you, beta? Trying the question or not? Sai, Reddy, Padmakant, Dinesh, Kevin. See, the population has increased. Well done. Chalo. Again, keep on telling you always, answers don't matter. Trial, the passion, the hard work, that matters. Let us start. Number 1, sketch, already there. Number 2, isolate the bodies. Here I'll isolate the bodies just for the sake of understanding, because two bodies are very close to each other. So I'll just isolate them so that you understand. So one body here is this block. Where is the other body? I only find one. I only see one. Where is the other body? Anyone sees the other body? Or am I the only one who is seeing two bodies here? Yes, Santosh. Yes, Deepak. The other body is string. So here comes my revolutionary string. Point A, point B. That is my other body. Let us draw the free body diagram of the first body. One is 50, other is N. Okay. Now there is a force acting on this. The string is trying to pull it. This is TA. Do we understand the meaning of TA? Do we understand the meaning of TA? What is this TA? What is this TA? Tension at point A. Please remember, tension at point A. Now let us first, okay. Now let us think about the other factors. The other factor being the free body diagram of this. So what is free body diagram of this? This 10 kg will go down. So it becomes 100 Newton. Now something has to support it. Something has to support it. So who is going to support it? Probably the person who is pulling it is supporting it. So he'll get some normal reaction. From where he's getting the normal reaction? Probably he's getting the normal reaction from here or normal reaction from here. Are you getting my point? It is getting supported somewhere. Something is supporting it. So this normal reaction will be equal to 100. Normal reaction N1 plus N2 will be equal to 100. Do we understand this? It is getting supported somewhere. I'm not worried about those. Now let us look at the tensions. At point B, 45 Newton acts. Yes or no? And at point A, remember, string always pulls. So TA acts here. Yes or no? TA and TA are same. TA and TA are same. String is trying to pull the block. Block is trying to pull the string, TA. Now from this diagram, you can understand what is the force at point B or tension at point B, and tension at point B is, tension at point B is, say, tension at point B is 45 newtons. That is equal to the force that we have applied at the point B. Okay. Now, let us look at where the system is going to move. We all understand where the system is going to move. This system is going to move here. Here. If this string moves with an acceleration A, this block will also move with the same acceleration A. Do we understand this? Can I have some raise hand that we understand this? Now look at this. Now look at this equation. The green one. N is equal to 50. The normal reaction. I got the value of normal reaction. N is equal to 50. The green one. The green one. The green one. The green one. Look very closely now. The blue one, which has become green one now. So what should I do? I undo it. I erase so that I don't create confusion. TA. Now, the blue one is one force TA here, and this body is accelerating here. So what is the equation along x-axis for this body? What is the equation along x-axis for this body? TA is equal to 5A. Do we understand this? The blue equation. Do we understand the blue equation? Do we understand the blue equation? Do we understand the blue equation? Yes or no? Please tell me. Do we understand the blue equation? Yes, sir. Let me call this equation as equation number 1. Now let us look at the equation on the x-axis. I don't need equation on y-axis for the rho. No one is asking me reaction on the rho. Here I have 45. 45. Here I have TA on this side, and I have acceleration on this side. 45 here, blue one, TA here, and A here. What is the equation of this string now? 45 minus TA is equal to MA. M is 10. That is the equation for x-axis for the string. Yes or no? Now I can add equation number 1 and equation number 2. TA will get cancelled. 45 will be equal to 15A. That implies acceleration will be 3. Acceleration will be 3. I can put the value of acceleration here or here. I can get the value of TA. TA becomes 15 newtons. TA becomes 15 newtons. And see, the tension at both the points are not same. They are different. Why are they different? Why are they different? Why are they different? Because this string has mass. Do we understand this? This string has mass, and therefore tension at point A and tension at point B, the yellow ones, are different. Do we understand this? Okay. So on this question, I will end today's class, and I hope that you liked it. We'll meet again in the class day after tomorrow. We'll do 1 or 2 more questions on this. See you there. If you have any doubts, you can ask those doubts. Else, from my side, the class is over. Take care. Stay healthy. Stay happy.